To problem number 2. They were giving us the xy plane position of a particle moving, and we have the velocity vector and the position when the particle is at 0, t equals 0. So we're trying to find the speed of the particle at t equals 1.2. So we have to write the speed equation now, which is square root of derivative of x at 1.2 squared plus derivative of y at 1.2 squared. And just plug it in the calculator, and that should give you 1.271. And this is like vt. And then they're also asking for the acceleration vector, so we need to find the coordinate also at t equals 1.2. So we know that acceleration equals to derivative of v, and we're trying to find the vector, so this is going to be second derivative of x 1.2, second derivative of y 1.2. Plugging this in the calculator should give 6.247, and this one 0.405. So this is the acceleration vector. So question B, they're asking for the total distance this particle traveled over the time from 0 to 1.2. So we know the equation for total distance, which is distance equals to integral from 0 to 1.2 of the speed. So first derivative of x t squared plus t squared. Okay, so plugging this in the calculator should give 1.01. Okay, for question C, find the coordinates of the point where the particle is the farthest to the left. So we know that when dx over dt equals to 0, dx over dt equals 0 at like t equals 1. So we're going to find the coordinates. So x of 1 equals x0 plus 0 to 1 t dt. And then this, so x of 0 we know is -2, and then plus that should equals to -2.604. Okay, so we're going to do the same for the y coordinate. So y0 plus from integral of 0 to 1, integral of derivative of y dt. And y0 equals to 5. So this equals to 5.41. Okay, so they're asking, so we still have to like conclude. So I'm going to say dx over dt changes from negative to positive at t equals 1. So there is a relative minimum here, but since this is the only critical point, this is just the minimum. So we're gonna, so we know that there's a minimum at t equals 1. So the particle travel farthest to the left at, and we're just gonna put the points we just calculated in, which is -2.604 and 5.41. Okay, and they're also asking, explain why there is no point in which the particle is traveling furthest to the right. And there can only be like a reason, which is because the particle is moving to the right. So that means it's just constantly going to the right. So there's no farthest right point. So we have to put this into words. Since dx over dt is greater than 0 for when t is greater than 1, the particle moves right for all of t that is greater than 1. There is no point farthest to the right.